Which number is bigger, square root of 2 or the cubic root of 3? Used to be a Cambridge interview question. From today's perspective, of course, very easy. So obviously, naturally, we want to raise to the power of 2 on both sides and then compare, since they're both positive. So all we have to do is square root of 2 raised to the power of 2 and compare that with the cubic root of 3 to the power of 2. And so that automatically gives us, so here we can just put square root of power of 2 inside the square root. So we have 9 cubic root. But we still cannot tell. But what we can do is we can raise the power of 3 on both sides so that this cubic root is gone. So all we have to do is compare 8 versus 9. So obviously the answer is clear. So this one's bigger. So the next question is, can we generalize this question? So in fact, the background of this question, I think, is, in general, we want to determine, so if you want to continue, ask, which one is bigger, cubic root of 3 or the fourth root of 4? Right, that's next question. So generally we see that we can rewrite it into the third root, third power. That's the same thing. Also, that means the fourth power. 1/4 the power. And so the lowest common multiple of 3 and 4 is 12. So we say raised to the power of 12 on both sides. And so 1/4 to the power of 12. So all we have to do is compare, so 12 divided by 3, 4, versus 4 to the power of 12 divided by 4, 3. Right? So all we have to do is compare. So 3 to the power of 4 is 9 to the power of 2. So 4 times 4, 16. 16 times 4, 64. So 81 versus 64. So this time, this one is bigger. Right? Previously, the right-hand side is bigger. This time, the left-hand side is bigger. So if we raised, say, generally speaking, which one is bigger? The nth root of n or the n plus 1th root of n plus 1? Right, that's the pattern. So each time, this one is 1 unit bigger than that one. And the root is 3, third root, second root, fourth root, third root, n plus 1th root, and nth root. So according to the same logic, same method, we can say all we have to rewrite it into the power of 1 over n versus this power is just 1 over n plus 1. So again, the lowest common multiple of n and n plus 1 is just, generally speaking, n times n plus 1. So we raised the power of n times n plus 1. Over n times n plus 1. So this time n and n cancel out. So all we have to do is compare this one versus n plus 1, the power of, this time n plus 1 cancel out. We're left with just n. So if we just divide this over, we want to compare the ratio. So 1 plus n to the power of n divided by n to the power of n plus 1. So as long as this is, for example, greater than 1, then that one is bigger. If this is smaller than 1, then this one is bigger. So let's see what's the ratio, right? If it's less than 1, so meaning this one is smaller. If this is bigger than 1, so means this one's bigger. So in fact, that is equal to over n to the power of n plus 1. That is equal to, separate these ones. So it can be separated to n to the power of n times n to the power of 1 into those two, n plus 1. Again, we combine this power to n, this power to n, combine n plus 1 and n together. N plus 1 over n altogether to the power of n. That's the common power. So again, I have n at the bottom. So this is in fact equal to n plus 1 over n to the power of n. And this part is the definition of e, the base of natural logarithm, as n goes to infinity. The definition times 1 over n. So, which means this part, as n goes big enough, this part cannot go to infinity, but n can go to infinity. So, which means the whole thing will be less than 1 in the end. Because this part can be small enough, this part cannot. So in fact, we say, in fact, I have the n plus 1 root of product of several numbers. That is 5 over 6 to the power of 6 times 1 to the power of n minus 5. So here I have a product of, here I have 6 numbers times together. Here I have n minus 5, this many ones times together. So in total I have how many numbers? So 6 numbers here. So n minus 5 numbers. So n plus 1 numbers multiply all together. So I have the arithmetic and geometric mean inequality. So this is the geometric mean of n plus 1 many numbers. So less than, strictly less than, because those numbers are different, right? 5 over 6, different from 1. So the arithmetic mean over n plus 1, the sum of those numbers, right? The sum of 6 of 5 over 6. So I have 5 over 6 times 6. A sum of this many ones, n minus 5 many ones. So n minus 5, that's their sum. So here is 5 plus n minus 5. So n over n plus 1. So here I raised to the power of n plus 1 on both sides. And I have 5 over 6 to the power of 6 times 1. That is less than n over n plus 1 to the power of n plus 1. And we take the reciprocal. Reciprocal of this is n plus 1 over n to the power of n plus 1. Change the direction. I used to be bigger than that. Now it's less than the reciprocal of that. 6 over 5 to the power of 6. And that is just equal to 6 over 5 to the power of 3 to the power of 2. That is equal to 216 over 125 square. And 2 times 125 is equal to 250, bigger than 216. So the whole fraction is less than 2, and less than 2 to the power of 2, less than 4. So this one can be no larger than 4. Right? At the same time, this is bigger than the reduced power by 1. n plus 1 over n to the power of n. the base is bigger than 1, obviously, and power reduced, so the whole thing is reduced. So this is equal to 1 plus 1 over n to the power of n. Now that's exactly that, the definition of E as n goes to infinity. And so that we immediately say this can be no larger than, of course, here I require n to be bigger than 5, because otherwise it's meaningless, because this means this many ones times together, right? N minus 5 has to be positive integer. So, right, so less than 4 over n. And so, like I said, as n gets big enough, this can be no larger than 1, strictly less than 1, as long as n is bigger than 4, combined with this, so bigger than 5. Okay? So that answers our question. So, like I said, right? As n is big enough, ratio is less than 1. So which means this is definitely smaller than that. So which means this will be bigger, this bigger than, so this bigger than that. Bigger. And so the rest we can easily examine. So the rest is n equals, we've already checked when n is equal to 2, that is the original question, right-hand side is bigger. N equal to 3 we've checked, so left-hand side bigger. N equals 4, we haven't, and I'm not gonna check that, so n equals 5, easily verifiable, I believe. So those two all just means left-hand side is bigger.